Hi everyone, we're from Group 10 and the experiment that we're going to present about is UV visible. So moving on to the introduction. So what exactly is UV visible spectroscopy? It is an analysis of materials like trace elements with the wavelength ranging from 180 to 780 nanometers. Aside from that, it is a simple and low-cost form of analysis that produces a data or results that you have the units of parts per million, which is also known as ppm. This is the UV spectrometer that we use. The main theory following in this experiment is actually Beer-Lambert law, which is used to determine concentration of a specific analyte in clear liquid sample at specific wavelengths. The equation follows as A equals to epsilon times L times C. The meaning of A, epsilon, L, and C is actually stated as below. The main aim of the experiment is to determine the concentration of caffeine in several commercially available beverages. There are 4 objectives behind the experiment, which are stated as below. So, moving on to results.
Hey guys, let's discuss about the results of this experiment. The results are based on Beer-Lambert's law. As can be seen, a sample is measured under the instrument before calibration. The observed peak absorption of the caffeine sample occurs at 269.1 nanometers. Calibration of instrument is essential to establish the relationship between the output and the accepted values of the calibration standards. This relationship is then used to transform measurements made on test samples into estimates of the amount of analyte present, which is based on Beer-Lambert's law. With known concentrations of caffeine, the absorptions at 269.1 nanometers were recorded and the calibration graph was plotted. A linear relationship is observed. The value of R square is 0.9958, hence R equals to 0.9979. Coefficient R is a measure of the degree of correlation, not linearity. A lower value of R doesn't necessarily mean there is no correlation, but it could mean the relationship is not linear but still exists. As shown by the graph, X and Y are very closely correlated since R equals to 0.9979. Alright, let's take a look at the tabulated values of different caffeine concentrations and their absorption values. When there's no dilution, strongest absorption values are recorded. Based on literature values, U1 could possibly be decaffeinated coffee, U2 with the highest concentration can be pressed coffee, U3 can be instant coffee. U5 and U4 have close concentrations, hence they could be black or green tea respectively. For 10 times dilution, 1 milliliter of raw sample was taken and mixed with 9 milliliter of distilled water. All concentrations recorded were approximately 10 times lower, hence linearity was maintained according to Beer-Lambert's law. For 50 times dilution, 2 ml of sample B was taken and diluted with 8 ml of distilled water. The absorption values were getting close to zero but still fell under Beer-Lambert's law, hence linearity was well maintained. This graph shows the behavior of different caffeine concentrations against absorption values, hence it's obvious that absorption is directly proportional to concentration.
We are now going to discuss about the discussion of the UV experiment. Here's the graph of the absorbance against the concentration in terms of ppm, and from the graph we can actually see that It is a straight line graph, and the equation and the R-square value are shown in the graph. From the graph just now, we can actually see that the adsorbance is directly proportional to the concentration, and the R-square value is high, which means high accuracy of the result, and the deviation occurs maybe because of the errors. So if the standards are prepared in different concentrations, will it be any difference to the calibration graph? So this is the graph of the adsorbance against the concentration, and the concentration does not matter as eventually it will follow the same pattern of the straight line. So even in different concentration, there will be no difference in the calibration graph. And also, based on the results, we can actually find out the confidence interval. And this is the equation for the confidence interval, and also the value of n, which is 1, and also the values of t for 95% and 99%. So here's the result, and from the result we can actually see there are some negative minimum values, and also the maximum value is quite high. And for set C, there is negative minimum value again. You might ask why. This might be because of the errors occurred during the experiment, and also when the values were taken, and we believe that this can be overcome by the improvements, which we will be talk about it in the slide later. And from the literature values, we can actually find out that the crystal coffee has the highest concentration, and from the values here, we can actually determine the type of the wastewater by following the sequences of the concentration.
And recorded values. A low concentration can be used when considering Beer-Lambert's law, so that the samples fall within the calibration standards. According to the graph plotted, most of the values fall within the graph of the standard concentration, so a directly proportional relationship can be proven. Some deviation might create differences when compared with literature values. These are the two main deviations which affected our experiment, which are leftovers and air bubbles. Some deviation might affect the results shown when compared to the literature values. There are always errors in experiments. Any abnormality can be seen from calculating the mean, then standard deviations of the results. Based on the standard deviation calculated, we can see that at U2 there is a high standard deviation. A high standard deviation indicates that the data points are spread out over a wide range of values. For this table, the standard deviation calculated are close to 0. A low standard deviation means that the values obtained are spread across a narrower range. For 50 times dilution table, the standard deviation values are smaller compared to the 10 times dilution table, therefore showing that it has a narrower spread of values. By tabulating the data we have gotten and calculating the standard deviation, we can say that Beer-Lambert's law is more reliable at lower concentrations. More readings are taken to get a better mean value. Ensure the experiment is carried out with the same procedure to avoid any kinds of deviation. Ensure that there are no contamination and sedimentation of samples to obtain a more accurate reading. There are other ways in measuring the concentration of caffeine in an unknown substance. These are 3 different ways to analyze caffeine concentration. HPLC is the recommended process for determining an unknown compound, but it is an expensive method and some people do not have access to it, so other methods are considered. 2 main factors are considered to determine the most suitable analysis, which is cost and time. By considering the factors in terms of cost and time consumption, UV-Vis is considered a cheap and quick quick method.